Hi guys, today we are going to solve a Division 1 problem. Its rating is 2200 and is posted by Rahul, right? So let's begin. As always, we are going to explain this problem by introducing the example here, right? So in the example, we have a number here. It tells us the length of the following array. So we got 1, 2, 3, 4, 5 numbers in the following array. And the output should be an array with the same number of numbers, right? 5 numbers. And the output array should satisfy two conditions. The first condition is that if you pick any two of the numbers from the output array, the two numbers common divisor should be 1, right? For example, if you pick 1 and 5, the common divisor of 1 and 5 is 1, right? And if you pick 3 and 8, common divisor is 1. If you pick 1 and 1, the common divisor is still 1. So that's the first condition. And the second condition is that the distance between the two arrays should be minimal. So the distance is calculated by minus the two numbers between the two arrays, right? So if you calculate 1 minus 1 equals 0, 6 minus 5 equals 1, 4 minus 3 equals 1, 2 minus 1 equals 1, right? And 8 minus 8 equals 0. So if you sum up them, you get 3, right? I can tell you in this test case, 3 is the minimum number if you want to satisfy the first condition, right? So there is a very special case here. So if you output 1, 1, 1, 1, 1, right? You choose 1 for each of the numbers. You will satisfy the first condition, right? The common divisor between 1 and 1 is 1, right? But you might not be able to satisfy the second condition, right? So for example, in this case, 6 minus 1 equals 5, already bigger than 3, right? So it's not the minimal. But this guy can be very useful for us to narrow down the final answer, right? How do we do that? Let's take a look. So each of the numbers in the first array is less than 30, right? Is described in the problem, right? So it tells us that the maximal value in the second array shouldn't bigger than 60. Why? Because let's say we choose 70 here, right? The distance between the first array and 70 is at least 40, right? Because the number in the first array is at most 30. So the distance between the number in the first array and 70 should be 40, right? And why don't we choose 1 here, right? Because the excuse me, because the distance between 1 and 30 is 29. 29 is smaller than 40. So in any case, we should choose 1 instead of the number bigger than 60. So that's the reason why we always choose a number less than 60, right? And the number of numbers in the first array is smaller than 100. It's quite a small number, right? We should pay attention to that as well. So let's dive deep more. So because the numbers in the second array, their common divisor should be 1, right? How do we leverage this condition? So we find out all of the prime numbers less than 60 here, right? There are 17 prime numbers. So we can use these prime numbers, right? We can use state compression here, right? Because the number of state is relatively small, right? If we took all of the states, there are at most 2 to the power of 17 states, right? It's a relatively small number. So how do we use this state? So let's say we already got 2 numbers, 1 and 5. So how do we tell the computer that we already got these 2 numbers? We can just use the state, right? So the state is a binary number, and it has 17 zeros at the beginning. This is the initial state, which is 0, right? And if you use 5 here, then we mark the 5 as 1, right? So the state becomes like this, right? So if you use a 3, then you can just do a OR operator on this this state and 3. Sorry, 1 second. Whoops, it disappeared. What? Sorry about that. Okay, here we go. So the state of 3 is here, right? 0, 1, 0, right? So only this is the state of 3. Only the binary number at position 2 is 1, right? And the current state is 5 because we only used 5 before. And we do a OR operator on current state and state 3. We can get 0, 1, 1, right? So 0, 1, 1 becomes the current state. And this state tells us that you cannot choose a number that has 5 and 3 as prime number anymore, right? So let's say you choose a 15. So 15th state is uh, 0, 1, 1, 0, 0, 0, right? Because it has two prime numbers as a divisor. So one of them is 3, one of them is 5. 3 multiplied 5 equals to 15, right? So this is the 15th state. And if we do a AND operator, state 15 and the current state, we can find out that the result is bigger than 0. It means these two guys share same prime divisor. So this number cannot be added to this state anymore. So AND operator is for us to check if a number can be added into the array, right? And the OR operator, um, let's take another example. If we want to put 8 into the array, then we just need to put state 8, which equals to 1, 0, 0, 0, right? Because 8 equals to 2 multiplied by 2 multiplied by 2, right? It only has one um, prime divisor, which is 2. So only the first binary um, code is 1, right? So if we do a AND operator on state of 8 to current state, we will get 0, which means we can use 8, we can add 8 into the current array. And in this case, we just need to do a OR operator on current array and state 8. And we are going to get the new state, right, of the array. And we can do the following again and again. So that's how we compress the state into a number, right? So with that being said, we can take a look at the um, dynamic programming state we are going to use, right? Here we go. So if ij means the minimum cost of first I numbers. So let's say F3 F3 0 1 1 0. So J is the state is in binary representation, right? It's in binary form. So the user prime state is J. So this guy means the array already used 3 and 5 as the prime divisor, right? And if I plus 1, so F4 J, let's say F4J equals to Fi J or K, right? So K here is the number we are going to use, right? For example, here we are going to use 1, right? And um, in the end, we're going to have actually, did we made a mistake here? Let me see. So this guy should be J or K, right? And this guy should be J. Because if initially we got a Fij here, then we change the state from J to J or K because we add a value K into the array, right? So here we go. Sorry for the mistake. And the previous cost should plus the new distance, right, between 2 and 1 here, right? So k here is 1, and the distance is 1 minus, actually k here is the state of 1, which is 0, right? Because state 1 doesn't have any prime divisor. And here k is 1, and 1 minus a uh, I plus 1. So we calculate the distance between the chosen number and the initial array, right? And we have to make sure that j and k equals to 0. So this is the previous state, and the previous state do a AND operate on k, means that the prime divisor of k doesn't haven't been used before, so it's not appeared in the uh, state j, right? So this AND operator makes sure that the common divisors are 1, right? So this is the way we calculate all of Fij. After we calculate all of them, we can choose a smallest f and let's say p, right? P here can be all of the possibility of states, right? From 0 to 2 to the power of 17 minus 1, right? So that's it. Let's take a look at the code. So first, we are going to read n. Then we are going to read the first array. And then we initialize all of the arrays. Then we are going to calculate the states of all of our candidate numbers, right? So for example, candidate 58 equals to 2 multiplied by 2, um, let me see, by 2 again. Actually, it's too hard to calculate. Let's choose a smaller number. Let's say 21 equals to 3 multiplied by 7, right? So we converted this number into a state. We are going to get these are the prime numbers, right? So it doesn't have 2, it does have 3, doesn't have 5, does have 7. So this guy transform into a state is like this guy in binary form, right? So this part is essentially doing this. Then this is the initial value of the state of our dynamical programming f, right? Then we're going to calculate all of the f with the previously described um, formula, right? So this guy here is just to make sure the prime divisor is not used before, right? And this guy is here just a small function to um, make sure that we get the minimum for each f, right? So if f is 0, if f is already 0, then we just set the value, right? If it is not 0, then we choose a smaller value, right? And this array, we use it to trace back, right? So let's say we find um, this is our output array, right? We find this number, this number, this number, this number, and in the end, we want to output this number in a reverse in a let me see, we want to output this number, right? So we need to have a way to trace back from the last number to the first, because we are going to choose the smallest number in Fn, right? So the last number will be the first number we found, and we are going to trace back, right? So this array is enable us to trace back, right? The part we trace back is here. So we output the current number, which is here, and we assign the value, the last value to the pointer, and we do this again. So this is where we trace back, and we are going to output the final array in the end. So I guess that's it. Hopefully it can help you better understand this problem. So good luck. Thanks.